So we know what we need to do first. What is it for this particular function? And when you look at it, what would you do first?
Factor simplify domain.
Correct. So this is already factored. There is nothing I can do here. For later purposes, when I distribute, but not for what I'm doing right now. When I distribute, this is power 1 and power 1/2. So this will be power 3/2 and minus 3x to power 1/2. But this is for other purposes, for later. So it's already factored. I cannot further simplify it. It's not a ratio. I can remove anything. So then I can directly go to the domain. Can anyone give us an idea about the domain of this function?
All numbers greater, all positive numbers.
Excellent, or 0, very good. Because this requires that x to be greater than or equal to 0. Awesome, thank you, Sean. So 0 to infinity. Good. So I have to plug in 0. What do I get? So remember, I start with the function. I exhaust the function, x and y intercepts and limits. Okay, so when I plug in 0, what do I get?
Zero.
Very good. When I find the limit at infinity, so now I need this. So let's find the limit as x approaches infinity from x to 3/2 minus 3x to 1/2. At infinity, which one counts?
The higher power.
Good. So where does it go?
Infinity.
Very good. I already plugged in 0, so now the only thing that I need to find is if there is anything else as the x-intercept. We already determined this. We already said x equals 0. And what is the other option?
X equals 3.
That's it. I'm done here. Now I move on to the first derivative. Ugly, I will use this, not this, this. So f prime of x, bring down 3/2 and subtract 1 from the power. 3/2 minus 1 is 1/2. Bring down 1/2. 1/2 minus 1, negative 1/2. If I don't factor right now, I will probably have difficulties in finding the critical numbers. Of course, I will factor out 3/2, and x is a common factor. And what is the power that I need to raise that common factor to? Or what is the power that I need to use? And the answer is always the smallest power.
Negative 1/2.
Negative 1/2. Awesome. The smallest power, always. Okay. So now I have to be careful. So this is completely out, so I will have a negative 1, of course. Because this times this will be that. But now from power 1/2, I subtract power negative 1/2. From power 1/2, I subtract power negative 1/2, which means 1/2 plus 1/2, which is 1. I have to change this into 3x minus 1, and I have to bring this to the denominator. It has negative power, 2 the square root of x. Now, critical numbers come from two sources. So the one from f prime of x equals 0 is x equals
one.
Very good. And the one from f prime of x being undefined is
Zero.
yes. Awesome. Because the function exists at 0. If the derivative does not exist, the second will not exist either. So I have to put 1 and I have to put 0. And immediately, whenever I put a number up here, I have to find the corresponding y value. Okay, where is my function? I lost my function. No, it's here. Okay. So the square root of 1 is 1. 1 minus 3 is negative 2. At this point, I study the sign of the derivative, but not the sign of the denominator. Why? Why I refuse to study the sign of the denominator? Because it is always remember the graph of the square root of x. It's always positive. So I only study the sign of x minus 1. Well, I know that before 1 with 0.5, this will be negative. And after 1 will be always positive. The moment of truth. I check these two rows right now. If there is a hiccup, I'll go back to the drawing board. Let's see. From 0 to negative 2, the function is decreasing. Oh, that's okay. From negative 2 to 0, the function is increasing. Oh, good. From 0 to infinity, the function is increasing. Oh, good. So I'm safe. The first two rows are okay. Now I'm going to struggle with the second derivative. And of course, I will be using this. Not this, not this. No, this to find the second derivative. So let's take a look. Going to copy it here. Okay, so the second derivative. Bring down 1/2. 3 over 4. X to 1/2 minus 1. Negative 1/2. Bring down negative 1/2. Two negatives. Positive 3 over 4. And x to negative 1/2 minus 1, which is negative 3/2. Yes, I have to factor out 3/4 and x. And you'll tell me which power will x have as a factor.
Negative 1/2.
The smallest of the two, always the smallest power.
Oh, negative 3/2.
Excellent. So of course this will be positive 1 because it's out. But now here, from negative 1/2, I subtract negative 3/2. So 3 minus 2 is 2, 2 over 2 will be 1. So now I change this into 3 x plus 1 over 4 the square root of x cubed. Okay, so this will be 0. So the second derivative is 0 when x is
1.
careful.
-1.
Excellent. No, it's not in the domain. Fine. It's even better. So now I need to study the sign, but x is always positive. This is always positive. The domain says 0 to infinity. This is positive, this is positive. Of course, it's a square root. I shouldn't even analyze this ever. It's always positive. And x plus 1 will all be positive because x starts at 0. Nice. So the function always holds water. Of course, and it makes sense because negative to positive, this is a relative min. So the function has to look like this if it's a relative min by the second derivative test. Done. I don't care about the work. I only want to see this. Nothing else matters. I don't care. This tells me what to do. Okay. I always start, and I should have not even put anything on this side. Okay. So I always start with the points. What points? I have 0, 0. I have 1, comma, negative 2. And I have 3, comma, 0. So the function always opens up, is concave upward at all times. It comes from the origin, decreases to the relative minimum, opening up, and then increases, it crosses at 3, comma, 0 and goes to infinity. That's all I need, that's all I care about. So this is the function f of x equals the square root of x, x minus 3. Any questions? Any questions? We will have a review for the test and we'll work on more problems. I like to show a trig. Yes?
So you said the test would be had on a Sunday night?
Yes, I would like to do that. Let me explain why. Because
I have to work on Sunday nights. So how would that work for me?
oh, we'll make arrangements. Don't worry about it. I'll give you other options. Not like Monday or above, but somehow maybe that Sunday earlier or Saturday, we'll work out something. And the reason I'm kindly asking for that is because I'm running out of time and I will not feel comfortable if I don't finish the material. I will not give myself a satisfactory grade if I knew that I did not finish chapter 5 and let you out on a limb and not be able to understand chapter 6 in Calc 2. So I have to have decent amount of time to finish chapter 5. Now we can do this if you'd like. I didn't even think till right now. We can have a class on a Sunday and the test we can keep it on Thursday. It's up to you. I let you decide. I didn't even think of it. But I just need the time to finish properly and show you everything I need to show you. So you can tell me we still have a week to discuss this. It's up to you. But I would prefer the test on Sunday and continue so that nobody misses class. And if there is a problem with the test, then I will meet with you and, give you other options. Okay, so my target is that my students understand the material, I finish the material, and I answer all your questions. So if I meet these 3 requirements in my head, then I think that I did a good job. But if I don't finish the material and I say, I can't, then you will get to Calc 2 and you will not understand chapter 6 at all. and past that. Chapter 7, where techniques of integration come in and to play, and a lot of other stuff. So I can't do that. So we can still talk about it, as I said. Okay. So I still have like a few minutes. I'd like to discuss, let me see where I'm at with this video here.